This is chapter 4, set D, number 1. It tells us that for a certain study in the Haynes 2, they found that for boys, we have an average of 146. So when I go through a problem, I always stop and write down what they tell me. So it tells me that the average equals 146 and the standard deviation equals 8. Part A tells us one boy was 170 centimeters tall. He was above average by blank SDs, or standard deviations. When we look at this, there is a formula that we use in chapter 5 to find this. It's called the Z-score, but they haven't taught it to you yet, so they just kind of wanted you to use some logic. When you look at it, if one boy was 170 centimeters, so 170 centimeters, if I minus 146 centimeters, because that's my average, that gives me 24 centimeters. So he's 24 centimeters. He's 170 centimeters tall, so he's taller than the average. So he's 24 centimeters above the average. But we need to find out by how many standard deviations. So to find out how many standard deviations, I can do 24 divided by, sorry, my standard deviation is 8, which gives me 3. So he's 3 standard deviations above the average. Now, I realize that it's kind of weird to just figure out by logic. If you're a math person, then it's probably easy. And if you're not really a math person, then you might be like, what was I supposed to do? If you don't really get it in this chapter, that's okay. Because in chapter 5, we figure out how to convert to standard units. And standard units is we do our x value that we're interested in, and we minus our average, and we divide by our standard deviation. And this formula always tells you how many standard deviations you are above the average. So what it's asking for is this is asking you to find the standard unit before it actually teaches you how to find standard units, which is okay. It was just a logic thing, but it is kind of interesting when you look at a person and say, oh, they're 170 centimeters tall. How many standard deviations were they above the average? So let's try B. So another boy was 148 centimeters tall. He was above the average by blank standard deviations. Well, first let's subtract it. So he's 148, our average is 146. So we'll do he was 148 minus 146 means 2 centimeters above average. But they didn't ask for how many centimeters above, they asked for how many standard deviations above. So I would do the 2 centimeters divide by my standard deviation of 8, which gives me 1/4. So he was 1/4, or the textbook might change it to 0.25, I don't know. Standard deviations above average. The reason that we want to do this is if you tell someone, oh yeah, he's 2 centimeters above average, but you don't really know what the scale of your data is, you might not realize, like, what does that actually mean? But telling someone he's just like a 1/4 standard deviation above average on something means that they're actually really close to the average. But if you're 3 standard deviations above average on something, that means you're actually like extremely tall. There's not very many people that are as tall as you. And all of this will make a lot more sense once we get to chapter 5, when we start talking about percentiles and normal curves and things like that. For C, it tells us a third boy was 1.5 standard deviations below the average height, and he was blank centimeters tall. So we have to reverse it. So 1.5 standard deviations, how many centimeters would that be? So that would actually be 1.5 times 8 centimeters, so 12 centimeters, sorry, I think I said above, but below average. So what height is that? So my height is my average minus the 12 centimeters, because he's 12 centimeters below the average. My average is 146. So my height is 146 minus 12, which gives me 134 centimeters. So that person that was 1.5 standard deviations below, I can tell you now that his height was 134 centimeters. Okay, and I'm not sure what D says. If a boy was within 2.25 standard deviations of the average height, the shortest he could have been is something centimeters, and the tallest is something centimeters. So let's use our same logic. So 2.25, right? 2.25 standard deviations is really 2.25 times the standard deviation of 8 centimeters. which gives me 18 centimeters. So the height is going to be between the average minus 18 centimeters and the average plus 18 centimeters. Because it just said 2.25 centimeters away. It didn't say if it was above or below. So it could have been 18 centimeters below, so we minus, and it could have been 18 centimeters above, so we add. So my average again is 146. 146 minus 18 equals 128. And we can do 146 plus 18, which gives me 164. So he had to be between 128 and 164. Again, more logic than you would think of, but we actually use this logic a lot in the next chapter and going on for the rest of the semester.